Alrighty, today's project is a YouTube play button for 500 subscribers. That's me right here. I'm excited. It's the first milestone that YouTube has for a YouTuber. You can start making money in the forms of supers and memberships and stuff. So I'm celebrating it by making a steel play button. We're going to learn about plug welds. We're going to use the plasma cutter a little bit. So stick around, see how we make this thing.
I started out by designing the two pieces on a 2D CAD program. You notice I used a lot of extra lines and squares and stuff just to line things up, and you'll notice that I designed both pieces on top of each other to make sure my plug welds lined up where they needed to. Once I got both pieces drawn on top of each other, I just highlighted the one piece and moved it off to the side. After the two pieces were drawn, I moved them over to the software that writes the G-code for me. I made sure the offsets were correct and then exported the files to the plasma cutter. I used 45 amp fine cut consumables on the plasma cutter to get the best detail that I could. It's still not great detail because it is a plasma cutter, not a laser or a water jet, but it turned out really well. Now I just need to remove all the dross, any sharp edges, deburr it, and then it's ready for assembly.
Alrighty, so we got our parts deburred. We've got all the dross off of them. There is this one. This is the plaque. This is the hole which is going to make the play button. We have the triangle for the play button. And we have the backer. Notice how it's a different finish. This is hot rolled. This is hot rolled, but it's pickled and oiled, so there's no mill scale. And that's a pretty big deal. You'll see why. And then the most important part that I thought was scrap when we started, this was going to be scrap, but now it's actually going to be the fixture that holds the triangle in place. So I was wondering, how in the world am I going to get this triangle in place, but also tack it from the back side? Well, if I just put this piece in there, and then this piece in there, and it's all flat down to the table, I just put the backing plate on, clamp it on, and then weld it. It's that easy. So I'm going to carefully make sure everything is upside down on the table. I'm going to clamp it all together, and then I'm going to plug weld it. If you're wondering what a plug weld is, that's why all these holes are here. When we sandwich these two plates together, I'm going to weld through this hole, making sure I weld the front plate, like the plaque, to the backing plate through these holes. Alright, so we got our blueprint here. This is the back of the part. That's why everything's backwards. This would be called the rear view if we were using the orthographic projection. So all the solid lines are object lines. Those are lines that we can see. All the dotted lines, don't mind the two different kinds of dotted lines. Those are all hidden lines. Those are things that we cannot see from this side. They're on the back side. So we have our 5 holes. Those we're going to plug weld. The plug weld symbol. We have our arrow. We have our reference line. We have our tail. Those are all parts of our weld symbol. We have our weld symbol, which is the plug weld symbol. We have 3/8, which is the diameter of the hole. And then down here, we have a number 5. That's because there's going to be 5 plug welds. If we didn't want to fill this up all the way, all the way deep, we would put a depth in there. 5 means there's going to be 5 plug welds. Also, if we didn't have that 5, let's imagine that 5's gone, and we see this right here. It says TYP, that means typical. That means every hole that size is going to get plug welded. All right, let's weld it.
I was very careful to make sure the table didn't have any berries stuck to it or even have any berries sitting on it. I didn't want the pieces to not sit flat and I also didn't want to scratch the face of that piece to where I couldn't grind out the scratches. Then I made sure everything was backwards and upside down. I put the back piece on centered and clamped it to the table. Then after that, it was easy, just had to plug weld it.
Alrighty, here it is. But man, look, it's discolored on the front. Oh no, it's the end of the world. Guess what? I came prepared. I knew that was gonna happen. That's why I went the pickled oil on the front instead of for the back, because I knew it was gonna change colors and I wanted to be able to make it look like I didn't screw up, because I didn't. So, since it's pickled and oiled, there's no mill scale, I'm just gonna hit it with this sander, and then it's gonna still have that same pickled and oil finish. It's gonna have a little bit of sander marks on it, but that's totally okay. That's kind of what I planned on. So, I'm gonna hit it with the sander, and then probably hit it with some WD-40 just so it doesn't rust like super fast or super bad. And then it's done.
Now I just have to sand it. I was using 220 grit sandpaper and it wore out pretty fast, and that oxidation was a little harder to get rid of than I thought, but it turned out better than expected. I just had to be very careful not to sand the mill finish off of the backer plate.
Alrighty, so the finished product, here it is. It turned out real good. I love the contrast in materials. This almost looks like stainless or aluminum, but it's just raw steel. We call that in the white. So there's that. The next one I make for 1,000 subscribers will probably be like aluminum or stainless or whatever the next more valuable metal is. I'll make it out of that. So anyway, hope you learned a lot. Hope you enjoyed it. See you next time.